Hi, class. What we'll look at right now is the transformations of sinusoidal functions, and then we'll get into the tangent function. So we've already looked a little bit at how we can alter the sine or cosine functions. Now let's look at the translation. So we've done this before. A vertical translation is a vertical shift, and basically what's happening here is when you do a vertical shift, you're moving you're creating a new baseline. Okay, so the original baseline is at 0. So for example, here if we look at the graph at the bottom here, here's your 0, and now you can either move that up or down, and so that you have a new baseline or a new midline. And then you have a horizontal translation, which we call a phase shift. Okay, so where the graph begins can move to the right or can move to the left. So let's look at how we go about sketching that. So again, what we can do is mapping. So let's say we're looking at this function here, which is a cosine function. We can take the original cosine, so just y equals cosine x, and we can make a table of values. So when we do a table of values, it's always best to do for one cycle. And then the other thing is to decide, are we going to do degrees or are we going to do radians involving pi? And so you look at the equation here, because it says 45 degrees, we'll use degrees then. Okay, so 0, 90, 180, 270, and 360. Okay, so 1, 0, -1, 0, and 1. Okay, so now let's map that for the new function. So what's happening here is your y value is going to go down by 2. So instead of 1, we're going to have -1, and then 0 will turn into -2, -1 will turn into -3, 0 is -2, and 1 is -1. Okay, so there's your y values. Okay, and now your x values, you're going to take away, because it's plus 45, so remember we're going to watch that, because it's plus 45, that means we're going to take away 45. So remember how it was the opposite? So if we start with 0, that's going to be minus 45. And then if we've got 90, that's going to be positive 45. Okay, 180 is going to be 135. And then 270 is going to be 225. So we're just taking away 45. And then 360 is going to be 315. Okay, so now what we do is let's put these points on here. So we can extend this a little bit further back. So this is let's extend this further back here. Okay, we can call this minus 45 over here. Okay, so this we can call this -1, -2, and -3. Okay, so 45 is going to be -45 is going to be -1, and then the 45 positive is going to be -2, so that's halfway between 0 and 90. And then we've got 135 is going to be -3. And then 225 is going to be -2. And then 315 is going to be -1. Okay, so here's your graph. Okay, so that's the graph of this equation there. Okay, and in terms of the domain and range, your domain is going to be, because it just keeps going left and right, is going to be all real numbers, and your range is going to be y is greater than or equal to -3 and less than and equal to -1. Okay, now let's do a sine function where we're involving radians instead. Okay, so same idea. Just start with your base function here. So y equals sine x. Okay, so same. Instead of using degrees now, again, because we see pi in the equation, we're going to use radians. So 0 pi over 2, which is the same thing as 90 degrees, pi, 3 pi over 2, and then 2 pi. Okay, so here we've got 0, 1, 0, -1, 0. Okay, so same idea. Let's map this now. So what's going to happen to your y is you're going to be adding 2. Okay, so instead of 0, you're going to have 2. Instead of 1, you're going to have 3. 2, -1 is going to become +1. And then 0 is going to become 2. Okay, so take care of the y. Let's look at the x. So now this time what we're going to do is, because it's minus, we're going to add. So we're going to add pi over 2 to each of these. Okay, so this is going to become pi over 2 instead of 0. Pi over 2 is just going to become pi. Pi is going to become 3 pi over 2, right? So like 1.5 pi. And then 3 pi over 2 is going to become 2 pi. And then 2 pi is going to become 5 pi over 2, okay, or 2.5 pi. So now what you do is, we want to do this over 2 cycles. Okay, so let's call this, so here's our 0 line, and we can go 1, 2, actually, let's make that a little smaller here. So here's, we'll make this 2 right there. And so we can, let's call this pi over 2. Pi, and then 3 pi over 2, 2 pi, and then 5 pi over 2. Okay, so pi over 2 is going to be 2. Pi is going to be 3. 3 pi over 2 is going to be 2. And then 2 pi is going to be 1. And then 5 pi over 2 is going to be 2. Okay, so we're going to get okay, so there's your, and now it knows how the question asks for 2 cycles. So again, when we want to do the second cycle, it's just going to follow the same pattern. So you don't need to do more mapping to figure out more coordinates. Just follow your grid. And so this is going to go there. And then back up. Okay, so there's your second cycle. And with what we're doing here, you can also you can verify this using technology if you want to see if it what you're doing works out. We'll come back to the technology in just a moment when we're trying to figure out an equation. Okay, so here let's look at sketch the graph of a function again over 2 cycles. This time it's a cos, and what you notice here, now we've got everything in there. Okay, so we've got the vertical stretch, a horizontal stretch, the phase shift, and the vertical displacement all into that equation. So we can do this in a couple of steps here. Okay, so let's start with the cos x, and we're going to be using pi here. Okay, so again here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and 1, 0, negative 1, 0, 1. Okay, so remember how we did this? We saved the translation for the last part. So we take care of the stretches first. Okay, so let's take care of the stretches first. So what's going to happen here is your y, you're going to be multiplying by 2. Okay, so you're going to multiply your y by 2. So 1's going to be 2, 0, negative 2, 0, and 2. Okay, and then your x, because it's a multiplication of 4, you're going to divide by 4. Okay, so remember how that was backwards? So this is going to give you 0, pi over 8, pi over 4, 3 pi over 8, and then pi over 2. Okay, so that takes care of the stretches. And now what we're going to do is we're going to do the shift. Okay, and so let's look at the y first. So the y we're just going to subtract by 1. So we get 1 minus 1 minus 3 minus 1 and 1. Okay, and then the x, where it says plus pi, so what that means is we're going to take away pi. So we get negative pi, so 0 minus pi is negative pi. Pi over 8 minus pi is going to be negative 7 pi over 8. Pi over 4 minus pi is going to be negative 3 pi over 4. And then 3/8 minus 1 is going to be negative 5 pi over 8. And then the last one, pi over 2 minus pi, is going to be negative pi over 2. Okay, so what you see here is all our values are negative, right? And so what we can do here is we can doesn't matter where you want to start, but just be careful with how you label this. So just kind of, let's ignore this this vertical line on the left here. Okay, so let's call this, doesn't matter where we want to start, but let's call this negative pi. Okay, so there's negative pi, there's negative 7/8, negative 7 over 8 pi. This is negative 3 pi over 4. And then we've got negative 5 pi over 8. And then this is negative pi over 2. Okay, so negative, and then the other thing is we can call, let's call this, so we'll call this 1. And then this can be negative 1, negative 2, and negative 3. Now when you do your grid, just the grid should always be labeled like how I'm doing here, okay, so that you know what the width and vertically what it represents. Okay, so negative pi is 1. Okay, negative 7 pi over 8 is minus 1. Okay, and then negative 3/4 pi is going to be negative 3. And then 5/8, negative 5/8 is going to be minus 1. And then negative pi over 2 is going to be 1. Okay, so this is going to look like that. Okay, and then what we can do here is we can do the second cycle. Again, the second cycle is just going to follow the same pattern. Okay, so there's the second cycle. Now let's answer these questions here. So it says state the vertical displacement. Okay, so the vertical displacement it basically is you're getting that from the minus 1 here. So that's telling you what. So the vertical displacement is equal to minus 1. Okay, so that basically says your midline, instead of being at 0, it went down to minus 1. Okay, so like this is your midline here. Okay, your amplitude is going to be equal to your midline to either up or to the maximum or to the bottom. Okay, so that's going to be equal to 2. Period is the length of one complete cycle. So here the period is going to be, so if you look at what's happening for that first cycle we drew, we went from negative pi to pi over 2, so this has a width of pi over 2, so your period is pi over 2, so that's how big one cycle is. Okay, the phase shift, okay, so the phase shift is in the equation there. Okay, so the phase shift is your horizontal translation, and so this one here is we went left by pi. Okay, so minus pi basically. Domain again is all real numbers. And then your range is going to be your maximum at the bottom is -3, and then your maximum at the top is or your minimum, sorry, is -3, and your maximum is +1. Okay, so what we just looked at in this example here can be summarized with this equation, and this is sort of resembles what we looked at with the regular functions, but this is a little bit different here. So there's your framework of the equation. A is your amplitude. Period, notice here, is given by 2 pi divided by b. So that's this is for both sine and cosine. Okay. Horizontal shift is going to be c, and the vertical shift is going to be d. Okay, so again, the same is true for a cosine function. For a tangent function, the period is given with pi over b. Okay, so it's a little bit different. So within that framework, we can figure out what an equation is. So here, what we're asked is to find sine and the cosine functions, and what we can do basically after we're done here is you can use technology to confirm that the equation, just type in the equation that you came up with and see if that works. So what we want to do is we want to get as much information from the picture first. So the way I would start is I would look for the midline. Okay, so if you notice, the top here is 2, +2, and the bottom is -4. Okay, so you got +2 and -4. So where's your middle? Your middle here is going to be -1. Okay, so that's, again, this is your midline or your baseline. Okay, so there's so what that tells you is right off the bat. So we're going to use the same letters we see above. What this tells you is that D is equal to -1, right? So you took the original baseline of 0 and you went down 1 unit. So that's why D is -1. Okay, your amplitude, you can look at it from the midline to the top or the midline to your bottom. So it's basically your maximum displacement. So if we look at it going down, it doesn't matter. So what this is telling you is your amplitude is 3 units. Okay, so here A equals 3. Okay, so don't worry about, it's A is 3 units down and 3 units up from the midline, right? So you can look at it either way. Okay, period is defined as the length between two repeating parts. So remember, we're looking at this from whether it's a sine or cosine, but it doesn't matter, the period's the same however we look at it. So I can look at the period by going between peaks. Okay, so let's say I look at it between peaks here, and so this width is equivalent to pi. Okay, so that's going to be the period. Right, and so now if I looked at this from a different perspective, if I looked at it, say, from the perspective of from here to here, okay, this is also pi. Okay, so it doesn't matter what you go by as long as it's repeating. Okay, so this is it's the same period. Okay, so we got the amplitude, the vertical displacement, we've got the period, and from the period we can get the value of b. So remember, for both sine and cosine, you can use this equation here. So pi period is equal to 2 pi over b. So what we have here for this particular graph is the period is equal to pi. So what that tells you is b is equal to 2 pi divided by pi, which is just going to equal 2. Okay, so if look at what we have here, we've got b, we've got a, and we've got d. Okay, so we have 3 of the 4 letters in that equation. So let's say we start with sine. Okay, so remember, we're asked to find both. So what we can write down for sine is y equals 3. Okay, so there's your amplitude, your a value, sine, and then 2, there's your b value, x minus c, I don't know what c is yet, minus 1, there's your d value. Okay, so now I got to find c. So when it's a sine, remember what happens with a sine. It has to do with where you start for a sine function, you start at 0. Well, it's no longer 0. So let's say our sine function here starts right over here, right? So this is say, let's call this the start for the sine. Okay, so if that's your start, then if you look at the picture, that's halfway between 0 and pi over 2. So what this is telling you is you shifted right pi over 4, sorry, between 0 and pi over 2 is pi over 4. So what you have here then is y equals 3 sine 2 x minus pi over 4, so that's your shift to the right of pi over 4, minus 1. Okay, and so that's your equation. Okay, cosine, we're going to do the same thing. Okay, so for the cosine, again, we've got the letters, everything except c, so let's look at how a cosine would start. Okay, so cosine starts at the top, and so like if we look at this cosine, this one here is starting over here. Okay, so that's your start for cosine. And so where is that? That's pi over 2 to the right of where it should be, right? Because it should be on the on the y-axis. Okay, so your cosine then is going to be y equals 3 cos. Okay, so see how that's the same, 2, same again, but the only difference here is going to be your shift, so this will be pi over 2 minus 1. Okay, and again, for both of these, you can confirm with technology. Okay, so what I mean is you can basically put those into Desmos and see what you get. Okay, and it should be the same picture there. Okay, and the last thing to finish up with here, I just want to spend a couple moments with the tangent function. So we've been spending a lot of times with sine and cosine, and so what you notice about the tan function is it's not continuous. Okay, so what you have here is you have gaps where and so you've seen this with your calculations where there's a certain value that's not that's invalid, or there's no value that corresponds to that. Okay, and so that's defined by these vertical asymptotes, which are the break in the graph, which prevents it from being continuous. So when you do this, you want to know where the vertical asymptotes are. So that's where your invalid value of tan of theta is going to be. And the other thing that we can draw it from this type of graph is that there is no amplitude. Okay, because the graph keeps going up and it keeps going down. It keeps getting closer and closer to that asymptote without ever actually touching it. Okay, the period of a tan function is going to be pi. Okay, so like if you look at the one in red here, so it's starting at here at 0, and then it's basically ending here at pi, right? So the gap between that is pi. Okay, so that's the period. Okay, and because there's no amplitude, there's no maximum and no minimum value. Okay, so there's not really as much we can do with the tan function as we can do with the other ones. Okay, so I'll stop here, and you can work on the corresponding questions.